Hello, my name is Angelie, and I will be presenting today with Neha, Ruoyi, and Elena, and we are the Data Clinic team for the Internet Equity Initiative. To provide some context for our presentation today, the Federal Communications Commission, or the FCC, is creating a database of broadband accessibility across the U.S. called their Broadband Serviceable Location Fabric, as part of the Broadband Data Collection Project. This is part of President Biden's greater push to increase funding for improving infrastructure in the U.S. $42 billion have already been earmarked for state governments and will be dispersed further in the coming year to localities to support unserved and underserved communities. To understand national broadband availability landscape, the FCC has historically relied on data provided solely by Internet Service Providers, or ISPs. At this time, entities outside of ISPs, such as state governments, organizations, and individuals, were invited to submit challenges to try to correct any misreported broadband internet availability. Now about the project itself. The residential or business locations corresponding to each reported challenge are called Broadband Serviceable Locations, or BSLs. Since the data collected by ISPs are not inherently reliable, there can be inconsistencies between what they report and what the resident or user of a business location actually experiences. In these cases, people can submit challenges of these inconsistencies, and these challenge reports make up the data we are working with this quarter. After a challenge is filed, it is reviewed by the FCC, and they make a decision whether the challenge was upheld or overturned, and they categorize their reasoning for either decision. This quarter, we want to work on building a pipeline with FCC broadband challenges, as well as rural and urban designations from the USDA and census data, such as American Community Survey data and files for geographic borders and demographics. Then, we want to aggregate challenges at the state and county level, as well as an even smaller geographic subdivision called tracts. And then for analysis, we want to explore geographic variation in challenges upheld and overturned rates and associations with socioeconomic and demographic characteristics.
Now I will talk about our data and methodology. The first part of our project included building a data pipeline to download new data from the Federal Communications Commission website. The goals of the pipeline included consolidating multiple data streams into one pipeline, creating a streamlined data collection for all data in each geographic level considered, and finally leveraging for analysis. Our pipeline consisted of two steps: data preparation and processing. Our data preparation step involved three data streams. First, we downloaded FCC monthly challenge resolution datasets. Second, we downloaded FCC fixed broadband availability datasets, which included data on broadband serviceable location for each technology within a state. Then we downloaded Census ACS demographics, rural-urban designations from United States Department of Agriculture website, and geographic boundaries. Finally, we joined our data frames using a common geographic area. Our processing step was implemented as follows. First, we break down challenges by technology type, category code, and outcome. Second, we aggregate features across geographies. The available geographies are state, county, and tracts, and these are geographies included in census data. Finally, we calculate rates of challenge resolutions. The main features that we used were technology types, category code, and outcomes. More specifically, technology type denoted the telecommunication materials used, such as cable, copper, GSO satellite, and other types. The category code feature is a description of reasoning for filing a challenge, such as denied service request or unavailable signal. Lastly, the outcomes feature is the FCC decision on an individual challenge. As for further analysis, our main transformations included calculating challenge rates per BSL for different category codes and different technology types.
Now let's take a look at our analysis section. We found that there are in total over 3,690,000 fixed challenges, indicating a significant scale. The majority of these challenges, approximately 70%, are upheld challenges. The remaining challenges are divided between those that are overturned at 15% and those that are withdrawn at 15%. The most common reason for a challenge being upheld is that the service provider conceded, representing 39% of these cases. The least common is adjudication by the FCC, which means the FCC has reviewed and confirmed the challenge, accounting for only 7%. Similar to the national trend, when we look at state-level challenge upheld rates, we observe that the upheld rates are generally high, with the majority of states having more than half of their challenges upheld. The bars are ordered from the highest to the lowest rates. And interestingly, for the two states with the highest upheld rates, the United States Virgin Islands and Rhode Island, they only have very small numbers of fixed challenges submitted, but are all upheld, resulting in 100% upheld rates. Here is a graph of total fixed challenges for each state in descending order. The states with more challenges than others are Nebraska, Virginia, and New York. However, since different states have different numbers of broadband service locations, other than the absolute challenge counts per state, we also provide a normalized comparison across states using challenge counts per BSL. Notably, only Nebraska stands out with a significantly higher rate of challenges per BSL, which may suggest more prevalent issues or active reporting in that state. The rest of the states show a more uniform distribution with much lower rates.
Here is a breakdown of technology types across the fixed challenge data. The largest category here is licensed terrestrial fixed wireless, which is a rural internet option that connects one location to the internet via radio waves broadcast from a terrestrial tower, with almost 60% of the total and approximately 2.2 million challenges. The next two largest categories are coaxial cable and optical carrier, which are both newer internet service technologies. These represent around 13% of the total at around 450 to 480,000 challenges each. Now, let's look at technology types and different category codes, which represent more detailed reasons behind the challenges being filed. The category codes have less data diversity than technology, with two codes, reported technology and reported speed not offered, making up more than 95% of the total data. As such, these category codes largely reflect the overall breakdown in technology type from the previous slide. However, when looking at some of the smaller codes, at less than 1% of the total, the technology type breakdown differs more greatly. For instance, requested additional fees has 70% of coaxial cable. Additionally, the bottom three category codes have a large representation of non-geostationary satellite, while overall non-geostationary satellite only represents 7.5% of the challenges. These three category codes have between 30 and 55% of non-geostationary satellite. This discrepancy suggests that some category codes may only apply to certain technology types, and service providers tend to have similar actions and service quality across technology types. Now, let's explore challenge upheld rates by category code, and this breakdown is sorted from the largest categories at the top to the smallest. As you can see, all category codes have an over 50% upheld rate, and the lowest upheld rate is signal not available at 59%. The bottom four category codes in terms of size, which are also the bottom four visually, all have the highest upheld rates. This may be because the total amount is so small that they have a ratio advantage. Interestingly, the category with the second lowest upheld rate is also the largest category, reported technology not offered, with an only 62% acceptance rate. Lastly, here is a similar breakdown of challenge upheld rates for each technology type, also sorted from largest to smallest. There is a much larger differentiation here between upheld rates and technology types versus category codes. The top three categories have between 65 to 70% of challenges upheld, and these challenges also make up a combined 83% of the total data. Two other interesting observations are that the non-geostationary satellite category has an upheld rate of 100%, while copper has the lowest upheld rate at only 18%. For both of these technology types, only 4 states have them as their top technology type, and they are not significantly represented in the data. Still, it's interesting that even one technology type would have a full 100% acceptance rate. Lastly, we will talk now about some future work that can be done for this project. One task that can be done is exploring correlations between demographics and challenge upheld rates, which could be broken down further by category, technology, or another attribute in the dataset to explore different correlations between these attributes, demographics, and the challenge upheld rates. Additionally, more county and tract level analysis can be done regarding urbanity to answer some of the following questions, including, does urbanity correspond to technology type or challenge category? And how does urbanity affect challenge upheld rates? This is the end of our presentation. Thank you so much for watching.